Titrations. Making a standard solution, we want to work out the moles, work out the mass. And then place the weighing boat on a digital balance and weigh out the mass of the solid. Tip it into a beaker, reweigh the boat, and it may still contain trace of solid. Subtract the mass of boat from the mass of boat and solid together to get a precise mass of solid. Add distilled water and stir until it is dissolved. Tip solution into a volumetric flask. Use a funnel to ensure it all goes in. Rinse the beaker and stirring rod with distilled water at the flask. Rinse beaker and stirring rod with distilled water at the flask. What this does, it ensures no solute is clinging to the beaker/rod. Top the flask up to correct volume with more distilled water and make sure the bottom of meniscus reaches the line. Stop at the flask and invert to ensure it is mixed. Now, using a pipette to measure a set volume of solution you want the concentration of, pour it into a flask, add a few drops of appropriate indicator to flask, then fill a burette with a standard solution of acid. Use a funnel to carefully pour acid into burette below eye level to avoid acid splashing into your eyes/face. Now you're ready to titrate. And what does titration allow you to find out? Titration allows you to find out exactly how much acid is needed to neutralize a measured quantity of alkali. Then we're ready to titrate. Do a rough titration to get an idea of the endpoint. And the endpoint is exactly where the alkali is neutralized and the indicator changes color. Then add acid to alkali using a burette, giving the flask a regular swirl. Add acid to alkali using a burette, giving the flask a regular swirl. Then do an accurate titration. Take an initial reading to see how much acid is in the burette. Then run the acid within 2 centimeters cubed of the endpoint. And this once we've done accurate titration, take initial readings, see how much acid in the burette, run acid within 2 centimeters cubed endpoint. We add it dropwise at this point, because if we don't add it dropwise, we won't see when the color change happens, and therefore we'll get inaccurate results. It will overshoot. Work the amount of acid needed to neutralize an alkali, aka final reading minus initial reading. This volume is the titer. Repeat the titration until we have concordant results. In titrations, indicators that change color quickly over a small pH range are used, so you know exactly when the reaction is ended. So I state the 2 main indicators for acid/alkali reactions: methyl orange, red, and acid yellow in alkali, phenolphthalein colors, and acid pink in alkali. Now, the reason universal indicator is a bit of extra stuff is not used is because the color change is too gradual, and also why we put the flask on a white tile, because it makes it easier to see exactly where the endpoint is.